Hi, now in this tutorial what I want to do is show you how we draw histograms. And what I've got here is a group frequency table. It records the distance thrown by a number of people throwing a ball. And we've got what we call here the classes. And it's very important that we understand what the classes represent. I mean, for instance, take this class here, 10 to 14. You'll notice that there's gaps, and we're meant to be dealing with continuous data here. And if it's measured to the nearest meter, it means that that distance d has to be greater than or equal to the lower bound, but less than the upper bound. Now, what is the lowest bound for this? Well, because we're measuring to the nearest meter, the lower bound must be 9.5 meters. We'll just put 9.5 there. And the upper bound, we're going from 14 to 15. If you're measuring to the nearest meter, it must be just less than 14.5 meters. And that means that the class width isn't from 10 to 14, just 4 units. It's actually 9.5 to 14.5. So the class width, we'll just call it CW, is going to be 5 units, the difference between those two values. So what's the class width for this one here that says 0 to 9? Well, you've got to be very careful with this one, because you can't throw anything less than 0 meters, unless you threw it behind you, I suppose, but let's excuse that. What we've got here is that d must be greater than or equal to 0. But then from 9 to 10, being to the nearest meter, you've got to be less than 9.5 meters. So the class width for something like this, CW, will be 9.5 units. Now, why am I doing these calculations? Well, when it comes to drawing a histogram, we have to calculate a particular value. It's called the frequency density. It's the frequency divided by the class width. And we've got the frequencies down here, and I've shown you the class width on a couple of these. So to do this, we need to construct another column called the frequency density column. So in order to put this first value in here for the frequency density, we've got to do 18 divided by the class width from 0 to 9.5, as we did down here, which is 9.5. So if you do 18 divided by 9.5, the value you get back is 1.89, and so on. And when it comes to working out the frequency density for the class 10 to 14, we've got to do 14 divided by the class width, which we know is 5 units, going from 9.5 to 14.5. And if you do 14 divided by 5, you get 2.8. Now you need to work out the other values, okay? And you might like to pause the video and give it a go. Okay, well, these are the results, and hopefully you're able to get them right. What we've got here is we would have 16 divided by 5, because this is going from 14.5 to 19.5. This one would be 15 divided by a class width of 5. 17 divided by a class width of 10. And what about this last one? The class width goes from 34.5 to 50.5. That's a width of 16 units. So 10 divided by 16 gives 0.625. Now that we've got our frequency density values worked out, what we need to do is plot the histogram. And so we take a bit of graph paper, put some axes on, and we've got on the vertical axis frequency density, and you can see it goes up to 3.2. So my scale here goes up to 3.5. So don't forget to label your vertical axis the frequency density. Now on the horizontal axis here I've got the distance measured in meters, and again don't forget to label your scales. And I've got 10, 20, 30, 40, 50 as you can see. Now to plot these, we first of all take our first interval, which goes from 0 to 9.5. So you've got to go to 9.5, and so 9.5 just slightly to the left of the 10 here. And then you've got to go up here to your frequency density, which was 1.89, which is going to be, say, well, let's just say it's about 1.9. So you're going to then draw a bar across there. And for the next one, we're going from 9.5 to 14.5. And it's at a height of 2.8 units. Well, you could try and draw this on a bit of graph paper, but what you should get when you're finished would look something like this. So you can get these bars here having different widths, but you must make sure that they join to one another because you're dealing with continuous data. And another point that's well worth noting on these is that if you were to rearrange this equation for frequency, multiply both sides, in other words, by the class width, can you see that frequency would be frequency density times class width? So if we had, say, this bar here, the first bar, frequency density, this measurement, times the class width gives you the frequency. And when you multiply this side by this side, that's the area. So what I'm saying is that the area of any bar, let's just shade this one in here for instance, that area gives the frequency. Because what we're doing is frequency density times the class width. Okay, well I hope that's given you an introduction anyway to histograms and can get you started. In later tutorials what I'll do is I'll run through some kind of common questions that you can get on this. But essentially make sure you remember this formula, and also don't get caught out by the class widths.